Let's begin section 2.3 with just a few review scenarios regarding what we've learned up to this part. In section 2.1, we struggled, your instructor included, with linear systems, not with the 2 variable, but with the 3 and 4 variable. There was a little more attention to detail, and that was linear systems. That means we had variables, and then we did the echelon method. And then in section 2.2, we learned about a matrix and using operations on it. And that was good. Much easier. We did learn about our calculator for a matrix, entering a matrix. All right. So now what are we going to do? Well, we're going to do more on matrix, but we're going to see what operations we can do. Now, remember in mathematics, we only have 4 operations. And they are, of course, you know them. We've done them since 2nd grade. Add, subtract, multiply, and divide. So knowing this, why is it so confusing and hard? Well, we're talking operations here, and we're talking shortcuts. And anytime you make a shortcut, so you're looking for patterns of things that need to take place so that you can get a good answer. And that's where we get a little bit hung up. And I'll try to do my best on that. So our first thing, and then we're going to jump in. My tactic on this one is explain as I go rather than list and then operate with that information. And we'll see if this is a better way to relay the information. So here we go. We want to find the size of a matrix. It's very important. And there are 2 types. Oh, well, actually 3. Square, column, or row. Square, column, or row. Well, I'll explain them as I go. So here we have 3 rows and by 3 columns because, well, that didn't come out right. I didn't want to write in this area. So because these are the same, we have a square matrix. Okay, and in further studies, we'll get to that involvement of the value of having those 3 rows, 3 columns. And it's written as a 3 by 3. Now, we have a little bit of experience from having done section 2.2 with the calculator, so we understand about this notation as we enter. Now, let's look at this one. Find the size of the matrix and identify square, column, or row matrix. All right, so we have 1 row and we have 2 columns. So we have a 1 by 2. Therefore, this guy right here is a column. because even though we have only one row, if it was a row one, we'd have multiple rows. So let's talk about that in case you have one. Oops, sorry. In case you have one of those in your homework. So if I had had 7, -5, -6, right here, this is a row matrix. And that's because we have 3 by 1, 3 rows. Here we had 2 columns. So that inference is what that refers to. And it helps in describing the multiplication process of a matrix later on, so that you understand when you use a column and when you use a row. So now let's understand the concepts of equal matrices. Well, that would be easy, right? An equal, a matrix is when they have the same rows by column. What this affords is that they're equal. They have the same rows and the same columns. And addition and subtraction can take place. It's like placeholders, right? You have to have the same, keep everything in line. All right, so let's do some examples here, and I'll explain it. First, we want to know if they're equal, and then the values of the variable. Well, this is a 2 by 2, and this is a 2 by 2. And in order to be equal, all elements in one matrix match all elements second matrix. So they have to be equal in all things, the placement of the elements and the location of the elements. So we can see in this that 3 equals 3 from A to B matrix. If this is my A matrix and this is my B matrix, the 3 in this matches that. Therefore, we understand then that -1 must equal X to be equal. We have on the next row, 0 must equal Y. So that is our, to make it equal, and -8 equals Z. All right, so we have found that first they are equal in size, and then now they are equal in value. So what do we do here? Let's talk about that. So we associate each row column position, not 2 S's, to match the other matrix. And find missing equal values. Very easy, but it can get more complicated as we go by because we want to make sure we understand what is going on. So here in this one, we have a 2 by 2, and this is a 2 by 2. So as I study this, I know then that this term and this term must equal. So I'm going to have s minus 4 must equal 7. I'm going to add 4, so s must be 11 to be an equal element. The second one is t plus 7 must equal 7. So I'm going to have, for that one, t plus 7 must equal 7. I'm going to subtract 7, so I'm going to have t must equal 0. Now I'm on the second row, first column, and in this one I have a negative 7 and a negative 7. So I know I'm in the right track because those are equal. And then I'm looking at the last one, 6 and r. So on this one, I have 6 must equal r. All right. So then I have a solution set. My solution set is a set of s equals 11, t must equal 0, and r must equal 6 to create an equal matrix. All right, there you have it. Nothing hard. Okay, so let's look at this next concept. The concept says we have addition happen and equals a outcome of a matrix. So let's talk about that. So first we have to combine, like order of operations, we're going to combine these two matrices to one. It's a 2 by 3. And then have it equal to the other 2 by 3. Okay, so it's going to be a multi-step. So we're going to do our first one. And we notice, sorry about that, I opened a window. So we notice that a plus 4 and 6a must be combined for that first step. So our new number for the row 1, column 1, is going to be 7a plus 4. Now we're going to do the second term. Our second term is 12 plus 1, 12z plus 1, and 4z. So I'm going to do that one. I combine like terms, and I get 16z plus 1. Now I'm at my third one. And let's see if I've got, oops, sorry. My third one is 8m and 5m. So I'm going to do those two. And I get 13m. All right. So now I'm on my second row, and I'm going to do that one. 12k and 7k. I add them together, and I'm going to get, it looks like 19k. All right. Now I'm going to do the next one, 2 and 4. Oh, that's nice. All right. 2 plus 4, and I get 6. Then I'm going to do my last second row, third column, 5 and 1 is 6. So my new matrix is again a 2 by 3 because they have to match. And we're going to use our numbers. And that is this. Oh, sorry. I got the wrong color there. Oh, I'm so sorry. Let me undo that. All right, let me get the right color. Sorry. So I'm going to have this and this. I'm going to have this and this. And then I'm going to have this and this. All right, so now I'm going to rewrite my matrix. So I'm going to have 7a plus 4. And then I'm going to have 16z plus 1. And then I'm going to have 13m. My second row is 19k. And I have a 6. And I have a 6. All right. Now I have this matrix equal to another 2 by 3, 18, negative 79, 52, and then I have a 76, a 6, and a 6. Okay, so then I know that this has to equal this. So I'm going to do that one first. So I'm going to subtract 4 from both sides. I'm going to divide by 7. And I have A has to be 2 to make that equivalent matrix. Now I'm going to do the second one. And that's this must equal that negative 79, making sure I've got the same thing.